Good morning, everybody. Morning, morning, good morning or afternoon online as well for our attendees and guests online. I hope you had a good, perhaps shorter, but good night. So let's continue. You may have seen the agenda for today, of course, but I will just give you a quick recap. So while yesterday we were really focusing on the past, the lessons learned, the experiences, and the current operations with a glimpse on the future, today is all about looking into the future and how we can further develop and move on the point merge concept and the TMA optimization activities further. So the first slot or the first session is really looking into the future, starting with presentations about AMAN and the technologies that we have available to make this happen, as well as project results and some projects that are looking into these areas. And then we will speak specifically about Point Merge version 1 and beyond, and also whether we can actually still innovate with Point Merge. And then after, the last is really the kind of a message that we would like to get from you to move forward, and that's creating a point merge community, how we can do that, how we should cooperate and collaborate and communicate going forward, and how we would like to do that together with you as a community. So that's pretty much from me. Let's kick it off with the first presenter, Thomas Gunther from Frequentis, who will be talking about their AMAN solution in relation to point merge. Please help me welcome Thomas on the stage.
Thank you very much, and good morning. We had a bit of a sightseeing tour with the bus this morning, but I was happy that I'm the first presenter this morning, but the whole audience was also in the bus with me, so that relaxed me a little bit. And it's not an issue to be too late. And I'm also happy to be kind of a transition from yesterday to today with my presentation, which I think fits perfectly. Yesterday evening, we had a nice dinner here, thanks to EUROCONTROL. I was sitting also at a table with people from the island, from the airport, from the airline, and also from the ANSP, and I think that's what definitely needed. So those collaboration is required, because any innovation that we do will only lead to something if those people talk together. So I think in our system, we have done very many things in isolation as well. So now it's about understanding each other. And I really like this event in the perspective that we have also stakeholders from different companies. I'm representing basically the industry. There's not so many people from the industry, so the suppliers in this room, but we always found it very important for us and also for our customers that we of course understand what your current needs are, where the future is going to. That's why I'm here. So I'm basically here to listen, but I'm also happy to give a short overview about what we do. I'm Thomas Günther from Frequentis. Frequentis is a larger company with multiple things. In our market unit, we provide traffic optimization solutions, including the arrival management system for Avinor for Oslo. I was glad that the AMAN was mentioned a couple of times yesterday. That shows that there's, of course, a relationship. We are, of course, aware that other ANSPs are also using other products from other companies, but the principles that have to be applied are, of course, the same. Yeah, these are the airports, just do that really quickly, where we have deployed our solutions, both arrival and departure management system. And I highlighted, of course, Oslo, because that was the first TMS implementation in the world. And we were almost about this at the same time deploying our arrival management system for Avinor a few months earlier. But of course, that went hand in hand initially, as also rightfully understood, of course, by Avinor based on the lessons learned beforehand. Also mentioned yesterday already, pretty much in the morning, was that point merge is also mentioned by the ICAO aviation system block upgrade. So ASPU is part of the strategic thinking of ICAO globally, what tools and what procedures should be implemented to modernize the aviation and ATM system. AMEN and point merge is also mentioned in the same sub box, I would say. So it also highlighted by ICAO that AMEN and point merge needs to work together. There's of course a number of other things that are promoted, which we support with the solution as well. But of course, we're focused today on the point merge. I was trying to find out yesterday a little bit, okay, what is the awareness within this group about AMEN? Obviously, some know very much, maybe others know what it does in principle. I mentioned already that AMEN, independent from which the supplier is, of course, does in principle always the same thing. And if we support point merge, it means it does not change the general principle of how an AMEN works. We only make sure that for this procedure, we add additional capabilities in line with the overall concept to support point merge. And that's basically summarizing on a very high level, not frequent specific, but generally how an AMEN works. So it collects multiple data sources, in particular flight plan data, of course, track data, and also weather data for the wind prediction. Takes it all together and predicts what we call an unimpeded landing sequence. So assuming that each of the flight was alone in the airspace, what would be the landing time for this flight based on the trajectory calculation that the AMEN does. Then second step is a runway sequence, considering some optimization potential, and of course, making sure that the separation is maintained. So second step there. And based on that runway sequence, given the fact that the runway is typically the most constraining resource, we provide advices to the concerned ATC controllers. Approach, typically, of course, also ACC. And if we extend the horizon further, then maybe even the neighboring FIR, or maybe even the neighboring ANSP. That means then it's a cross-border arrival management. And those advisories are very different from each of the installation. And then that's where it gets to a PMS specific thing. So the first two steps are everywhere the same. And then it's a question of how the advisories are presented to the ATC controllers. The most regular thing is a time to lose or time to gain advice. So how much delay needs to be absorbed on the flight path to the runway, because the runway is capacity constrained and there's other traffic. So you have to absorb 8 minutes of delay. That's a very generic but easy to use advice from the AMEN. And how that delay is being absorbed is then, of course, different means of delay absorption. We talked yesterday, and that was really interesting for me to understand the difference between flight planning and then what's the default route and what's in the FMS. But that's of course how we see it as well, that the AMEN arc is part of a delay absorption mean. So it's, if you absorb 2 minutes of delay on the PMS, that's of course part of the 2 minute delay time to lose of the AMEN. And if the delay goes further, then you absorb delay early in the flight. And then the fourth step is, of course, a continuous replanning and also considering some stabilization criteria to make sure that if something changes, that's considered in the sequence, but you don't want sequence changes too often. So it's always a balance between dynamic updates, but making sure that something stays stable. So that's the general principle, and I highlighted this in this green box. That's where the PMS specific comes in. So it fits always into the general principle of AMEN. This is just a selection of what I mentioned with there's different ways of absorbing delays. Of course, you can give a speed advice to say fly slower, ideally very early in the flight phase, maybe already before, or ideally even before top of descent. classical holding advice. If delay goes up above a certain threshold, the AMN would recommend to use a certain holding, maybe even multiple holdings. Alternative routes, if available. Weather mode, if something is really unpredictable due to the thunderstorms, there's also certain measures in the tool to do that. And point merge operations, which is the focus of this conference here. The chart may actually be outdated. I wasn't sure it's video. No, it's still okay, more or less. Good. I wasn't sure about that. So the two main things, and that was mentioned yesterday already a few times, but the two main things where the arrival manager supports point merge implementation is, first of all, make sure that the delivery of the aircraft into that point merge system is already pre-planned. So you do not want to absorb all of the delay into the point merge. It's not possible, of course, at all. So the first thing, and the ideal world, and also the wording ideal was mentioned yesterday, ideally you would have the procedure, but you don't have to use it because it's already, all the delay that needs to be absorbed is already absorbed beforehand. And you only use point merge for some flexible adjustment for any changes that may happen. I think that's the way that Avinor and also others use point merge as one resort to cover uncertainties in the whole predictions that cannot be removed. So there will always be uncertainty in the system. So that's maybe even the more important contribution of AMN to successfully implement point merge, that you have a proper means of prediction and delay absorption already beforehand. That's where it also gets interesting in terms of what we discuss later today. That part, that contribution of the AMN to do something before the flight is actually on the arc, that will even become more important in the future if we want to leverage all the things that have been presented in the demo yesterday. So that's, of course, also concerning the AC controllers who make sure that the flight flies a bit slower if there is a traffic overload predicted by the tool. And the second part is what we call the turn to point advice, that the AMN itself also supports the controllers to have a better prediction of what the point will likely be when the aircraft will or should turn to the point merge to actually utilize the runway in the most efficient way. So not to create gaps, but also make sure that separation is always maintained. So these are the two key components of the tool to successfully implement point merge. And as highlighted, that was also recognized by ICAO. It was also a number of presentations also from IATA to say you need to have both. And it was mentioned yesterday a couple of times. So it seems that, of course, you are all aware of that. Good. That's, well, I have two more or less similar slides, so I'll just move to the next one with a larger picture. So that's how, and we have seen a screenshot yesterday as well. For those who look very have good eyes, so there's a SAS flight 238. It's a mistake, so it's meant to SAS 238 flight, and the other one is SAS 1313. So the AMN provides always a timeline view, which is the right picture here. So you all know these systems from your own installations, with a timeline indicating either a certain target time at the runway or a certain target time at some reference fix. And the AMN for Oslo, in addition to that, besides the call sign, aircraft type, wake turbulence category, this is the time to lose. So how much time still needs to be absorbed for these individual flights to meet that sequence? So +3 means you still have to absorb for this flight 3 minutes in some way. And then the additional thing, which is then really specific at this point in time for Avinor, is the distance to turn, which is indicated in the AMN itself. So this flight, SAS 1313, has still to fly 3.0 miles before it should, according to the planning turn. The others still have a bit longer distance to fly. So this is the timeline view, and in addition to that, if needed by the ATC controller, or if deserved to have it, there's also a data interface to the main ATM system, where in the radar screen, of course not hours, that's part of the main ATM system, then can also be indicated the turn to point advice as a green line here. So this is the flight just mentioned, 3 miles to go to the turn point, and then there's also a visual indication in the radar screen to show this is likely the point when the aircraft has to turn. The other aircraft is, as I said, a bit further out, so much more distance to go, but also the aim and gives some indication of when to turn. Of course, ATC controllers are very aware of how to use point merge. Of course, they are not always looking at that planning specifically, but it gets, as I said, more and more important the further fine-tuning we want to apply for point merge. So to say, like what was discussed yesterday, let's remove level constraints because we already know that an aircraft will have to fly a certain distance on the arc. There's no need to fly to descend already to a certain level because we know there will be a longer distance. If you want to do that properly, you of course need to first understand what will be likely the distance on the arc, and you also need to know what is the descent profile, what is the effect on the altitude if you remove that that level constraint. So if you want to do that, you of course need a tool to predict those turning points. So that it's really a major thing. That's the transition to what we discussed today, to have those functionalities in the tool to make those potentials happen, in addition to the need that is already there for the aim and for the point merge implementation. So I'm really looking forward to the rest of the day. I was really impressed already by the demonstrations yesterday. Two more, and that's more the broader picture. And I was unsure if I presented here, but after yesterday, I'm confident that all those things belong together. So the two focus areas for us for the further development of the arrival management system from a larger perspective are two things. First of all, we are working with many customers on the integration of arrival and departure management systems. Of course, it's one resource, and if it's operated in mixed mode or dependent runway operation, so if there's a dependency between arrival and departures, of course, it makes sense to have a common planning, which is typically not the case if it's only an AMAN or only a daemon implemented. So we're heavily working on that. We have deployed a first solution in operation for Singapore, working on that for Hong Kong, also in discussion with Avinor to do that in the future. And what it basically does, it's more that the AMAN and the daemon become more a planning function to support the ATC supervisor in supervisors both in the tower and the approach to manage the runway utilization jointly. So we have capabilities like a joint what if function where the tower and approach look jointly at the prediction of the delays and can take joint decisions how to use the runway, one in mixed mode, the other one for arrivals for departures only, or when to apply a snow cleaning of the runway, what's the perfect slot for that, if there's some flexibility, or runway maintenance, to take all these decisions together based on the planning information that the AMAN daemon provides. So this is a topic that we're heavily working on. And the relationship to point merge is, of course, that if you want to do a very precise or even more precise planning of the arrival phase compared to what you do now, it's of course essential to consider any impact of the departure traffic on the gaps that you have to provide. So there's also a strong relationship. So the further we move on with that, of course, it will also allow to even better plan the arrival side. The screenshot you see here is just what I call the joint what if, and then the AMAN daemon would not only have a timeline, but also some diagrams indicating flow, punctuality predictions to support that joint decision making. And the other, even more high-level topic is, of course, trajectory-based operations. I was told when I recommended some agenda for my presentation, don't touch too much on TBO. It's a different topic, but I think it's not. It's point merge implementation is actually a key part of a proper TBO implementation in the future. So let's definitely look at it together. And I personally think maybe point merge may even be one of the key contribution to a functioning TBO in the future. Maybe that's only my view, but it should be looked together. So TBO for us means, in a very, very generic, rough view, that we will have opportunities to further close the current gap between flow management in EUROCONTROL provided by Network Manager and more tactical sequencing tools like AIM and Daemon, that those things are working better, even better together in the future, that there's a more consistent planning of the overall flight. Terminology here is FFI's release 2, so optimization or trajectory-based operations after departure. I think there's a huge opportunity to do some things in Europe. As said, it would mean that AIM and Daemon have further data exchange with the network manager to support that consistent planning, and also, and that's where it gets interesting also for us, to better consider airline or airport requirements in the planning of these sequences. So there's still a lot of work to be done. We as Segmentus are part of both NET TBO2 and ATC TBO project, and also part of the larger CSR projects in the future. So there's many opportunities to do something. We have always focused on trying to get something into operation rather than writing lots of papers. So I think both is needed, but especially the extended AMN is a good example for some measurable benefits that we have achieved together with our customers in the past. Yeah, that's basically it. So I'll try to give that, as said, the transformation or that transition between what we currently do. AMN is an essential part to have a successful point merge implementation, and it will, according to what I actually also only learned yesterday, even be a more essential part of anything that we want to achieve together in the future. Thank you very much.
Thank you very much, Thomas. And we move on to the next two presenters, Ian and Jose Manuel, who will talk to us about their project ORCI or ORCI. I'm not sure what the proper pronunciation is. Please help me welcome them on the stage.
Okay. Good morning, everyone. We are going to present you the ORCI or ORCI project. This is a CESAR-funded project, an exploratory research project. So it's some kind scientifically, even though we have seen that it's more than something scientifically. I'm Jose Manuel Enríquez. You can call me Chema. I work for INECO for the last 30 years as ATM expert and data scientist. And Ian?
Yeah, I'm from ISS Software in Paris. We're also on the same project. We did the validation platform and all of the validation assessments for the product that we built.
Go on. Let's start with a visual example. My intention is that you get familiar with the scenario that we are going to speak a lot during the following 30 minutes. This is the Lisbon, one of the Lisbon point merge system that Elio explained yesterday very well. What I want you to concentrate is that, of course, there are two point merge arcs, concentric ones, but the center is the PESEX point. I will repeat PESEX 1,000 times. So PESEX point is the center of the point merge system. And we are going to focus today not in the feeder actions that is part of the presentation with among all the previous sectors. We are going to focus today in the final sector, the one that is going to enjoy or suffer the point merge system, the executive controller working in the final sector. The main business objective from airport operations domain is maximizing runway capacity. My client told me, Chema, I want to increase 2 or 3 arrivals per hour in this airport. I say, okay, let's try to work in workload, in predictability. No, Chema, you haven't understood anything. So, okay, you can improve that if you want. I want 2 or 3 more aircrafts per hour in the runway. Okay, then let's focus on to ensure that the final spacing between 2 consecutive arrivals before transferring from the aerospace sector to the tower is as small as possible while maintaining the safety. So if we achieve that, we will increase the runway throughput. If the final spacing, for example, is 5 nautical miles, and you get 5.5, 5.6, 5.7, 5.6, 5.8, you are losing little by little some of that runway throughput that you have available. So let's try to minimize that extra non-desired buffer. We are going to try to minimize the final spacing buffer. Let's see if we can do it. At this respect, I'm going to explain now that the air traffic controller will use all the available software tools in the controller working position to do their job, of course. But it's true that they are going to use basically two main cognitive actions. They will perform two cognitive tasks. The first one is to think when is the best moment to provide the direct to PSX instruction to the arriving aircraft in the pink or in the red area. Okay, this is one of the first cognitive actions to achieve what? To achieve an intermediate. Let me check. I have broken everything. Sorry. I have checked. So the thing is that the intermediate spacing is the objective for that first cognitive task. Okay. The second one is, okay, as you know, the intermediate spacing is larger than the final spacing because of the compression effect, okay, and the wind effect and a lot of different deviations that you will have to correct or adjust using a speed adjustment. So, and this will happen in the green area. So these are the two main cognitive tasks that you have to do to achieve that the final spacing is as small as possible. So the objectives of ORCID are very linked to the first cognitive task that I have explained. So we will try to improve the accuracy of that intermediate spacing at PSX. We will try to provide support to the traffic controllers in order that this cognitive task requires less workload, and we will provide also more situational awareness. And the third one is a consequence in some way. We will improve the runway throughput because the final spacing will be smaller than nowadays, maintaining the safety. Now, I will try to explain how ORCID helps using a very simplistic approach, a little bit provocative, perhaps. Allow me this simplification. Imagine that the executive controller has a car with 10 units, 10 F4 available units. It's the ones that they have. In the current situation, let's say that they spend 5 out of those 10 units to the first cognitive task, to achieving intermediate spacing at PSX, thinking when is the best moment? Is now the best moment to turn direct to PSX? No, wait a little bit. So they spend 5 units to decide the best moment for that direct to PSX. Then the other 5 are focused on just fine-tuning the speeds to achieve the final spacing, to correct that compression. Some of them are going faster than expected. That's the current situation. With ORCID, we expected trying to do the following. Let's try that they spend less effort in making the same decision. So we are in some way one free cognitive capacity that will be added to the 5 units that you have in the speed adjustment. So theoretically, we are migrating part of your effort units to the speed adjustments area. But we are not only focusing on human and workload, but also in accuracy. Let me to simplify that we want to obtain a top 5 accuracy in the intermediate spacing, but let's assume that we obtain just 3 out of 5. Okay, we have done well, but not perfect. So these 2 lack of accuracy in the intermediate spacings, in some way, I will have to correct, apart from the compression effect and the wind effect, I will have to correct a little bit more this lack of accuracy in the intermediate spacing. So I will have to do 7 things instead of 5 to achieve the final spacing that my client is asking. You want to reduce and maximize the runway throughput. Let's say that with these 5 units and with 7 things to do, let's say that the accuracy of the final spacing is 3 out of 5. With ORCID, we are not only reducing the workload, but increasing the accuracy of that intermediate spacing. So in that way, we only have one lack of accuracy to be solved, aggregated to the usual ones. Then we have to solve less, we have to do less speed adjustments with ORCI, but additionally, I have one effort available more than before. So it sounds well. So theoretically, I have the ability to pay more attention on that fine tuning of the speeds at the end, and we can provide a final spacing much accurate than before. This was our expectation. Let's see the results a little. This is the hard part. So this is the definition we have discussed thousands of times, and I think that is impossible for you without seeing a video to understand. But let's try. So ORCI continuously, every second, is providing you with a figure with the predicted intermediate spacing at PSX between two arrivals. And that figure, when you see that figure, it assumes that you are going to start your phraseology right now. Okay. Iberia 331, turn left, direct to PSX. So when you see that number, it's expected that you start your phraseology. You don't have to discount mentally, okay, I will spend 5 seconds in that instruction, then the pilot will answer to me, then the pilot will do something in the cockpit, and then the flight will, it is already taken into account by the figure that you are going to see. So you don't have to think just to start your phraseology. Of course, being critical with the figure because the responsibility is still on your side. So you have to make that. I'm going like Spanish, sorry. I'm going to break a little bit the planning because I think that it's very hard for you just reading words. I think that is better. I don't know. I think that you are not going to see anything. This light is impossible to turn off. No, I don't get. Well, perhaps a little bit. Don't sleep. Don't take advantage of sleep. But then, so the figure number, I don't say don't is this one. This is our project. This figure. That's all. This figure is the result of all our work these years. And this figure is impossible to see. Sorry. The thing now is 0.63. I'm going to.
You can also see it at the top.
What?
You can also see it in the top of the screen as well.
Okay, yes, it's true. That figure is the same as this one, so you can take advantage of. Thank you, Ian. This is better for you. I'm going to do the play. Okay. This number is moving 1, 1.1, 1.2. This is the intermediate spacing between the United Airlines and the TAP Portugal that is already directing to PSS. So we want to obtain the intermediate spacing between this flight and this flight. So typically in the validation, we weighted to 8 nautical miles. But it's your decision. If you want 7.5, perfect. If there is not going to be any departure between 2 consecutive arrivals, you can decide 5. The only thing that you have to do is waiting to your number. I will wait for 8 nautical miles. I will not wait. I will be adjusting the speeds in the final approach, taking advantage that, okay, we can wait. So we can do other things just waiting for the 8 nautical miles or 7.5. So you make the decision. Once you see the 8, you should start your phraseology. United Airlines, turn left, direct to PSX, the same 4,000 feet, QNH 1015, for example. This video is double speed, so it's not real speed, it's double speed. But once they made the decision, for example, now, it's already, you know, this will be a nautical match. You have not seen, perhaps because it has been quick, but some seconds before, the previous couple of arrivals, the first one arrived PSX, and the second one was here, the TAP Portugal, and this is the Delta Airlines. When the controller decided the direct to PSX turning, the prediction was 8.11, and the real after they achieved PSX was 8.02. So the error in this example is just 0.1 nautical miles. Of course, it didn't happen always that. Ian will explain to you the results that we obtained. Now, if I recover the previous slides, because now I think that you understand better what is ORCI. So, ORCI is a machine learning based box. I don't like that word, but it's an artifact based on machine learning and has been trained on real data provided by NAP Portugal, more than 18,000 real trajectories. So it is not a theoretical model. It has learned from real traffic behavior, 18,000 traffic behaviors. It's like the executive controller having a colleague sit down with him or her that has an experience of 900 consecutive peak hours turning direct to PSX. So it's a help in that way. So we have two machine learning models, one for the arc for the people, for the flights coming from the east and for the flights coming from the west. And just to end my part of the presentation, and it's very intuitive. What this artifact is using, we have to use data from the both aircrafts, the aircraft that is on the arc, the follower, and the preceding, the one that is already starting directing to PSX. And we need just latitude, longitude, their flight level, their ground speed, their heading, and the weight turbulence category. That's all. And then we provide the ORCI distance, the figure. This is our fruit, that figure. Okay. And the time refresh originally was attempted 3 seconds, but Ian's is a software maker. It's almost 1 second, 1.5. So it's continually working. That's all from my side. And
Okay.
Floor to you.
Thanks, Gemma. Which one's which? This one. Okay, so I'm going to move on and talk about how we did this validation, how we implemented the platform, how we connected to the ORCI tool. So first of all, we wanted to align with the future Cesar vision of a connected ATM world, a service-based ATM. So we built a distributed platform, which allowed us to run the simulation using a legacy simulator of our own in Paris, at the same time as deploying the AI artifact in Madrid and also in Valencia sometimes as a service, and allowing the ATCO to work from their own ACC. So from Barcelona, we did Trombone, but in this case from Lisbon for the point merge. And we'll focus on the point merge. So the tools themselves, we set them up, we run them. The controllers finish their shift. They come in for an hour to do the validation experiment. They carry on working for 1 hour to do the experiment. They answer the questions. We record all of the outputs and we make the analysis at the end. The validation itself for Portugal, we had 8 different ATCOs who worked the validation. Each ATCO was an expert in arrival management. They worked with Helio. In fact, Helio even carried out one of the scenarios. It was mixed mode runway operations for single runway in mixed mode. And we required 6 nautical miles to allow a departure in between 2 arrivals. That's the 3-minute gap that's necessary. And as Helio said yesterday, that gap is gold dust. Not being able to get a departure off when you want to is extremely costly, and it's one of the most inefficient things for the Lisbon airport. So that's the ultimate goal. And in the case that we coordinate and there's no departure in between, we can reduce the separation to 3 nautical miles at the threshold, or equivalent weight separation, depending on the combination of the pairs. So to achieve that, as Helio said yesterday, we actually targeted 8 nautical miles at PSX for the 6 nautical miles at the threshold, and reduced it to 5 if we coordinated no departure in between. There was a tower controller representing the coordination, and every so often we would say to the controller who was active in the validation, you can reduce the separation this time. There's no departure necessary between United 642 and Delta 144 or whatever. We also deliberately built an extremely high demand scenario. So the normal capacity for arrivals in very busy periods at Lisbon with segregated mode is 23 arrivals per hour. We pumped that up to 33 arrivals per hour. We couldn't go higher than that because we did not want to exceed the capacity of the point merge arcs themselves. We did not want to get into a situation where we had to hold at the beginning of the point merge prior to entering it. So we pushed as many flights as we could in to really challenge the point merge arcs, the linear holds, to the maximum capacity without having any separation issues, any additional extra issues to carry out in the point merge system. We did 16 overall exercises, so 8 baseline and 8 with ORCI support for each controller, and each exercise was around 30 to 35 minutes of control, depending on how the control went. Sometimes it's shorter, sometimes slightly longer. So some metrics initially. Oh, I've done the same as Chima. What did you do? Thanks. So the first metric, the most important one, the target spacing accuracy at the PESEX merge point. So you can see in blue the baseline. This is all scenarios, all 16 scenarios. The blue is the baseline scenarios when the ATCO are working using their own skills. And you can see that the blue is quite spread. We've got quite a wide spread at the far ends, and in the middle, kind of relatively same height, but between minus 0.6 and plus 0.4 nautical miles at the PESEX. Yeah, so almost a 1 mile spread. But when we introduce the ORCI tool, you can see that that spread narrowed extremely well, and many of the predictions, many of the actual achieved target spacings were in the 0 to 0.1 nautical miles at PESEX. So the ATCO were immediately able to increase that predictability at PESEX, reduce the spacing inaccuracies at PESEX, and as a consequence, they could spend less time trying to actually fine-tune in the final approach system because they were already well tuned at the merge point. Secondly, we measured the arrival rates for the point merge. Because the point merge is already a nicely structured system and is already a system that allow the controller to be more accurate, we did not see enormous increases in the runway rates. And you see afterwards with Barcelona, which has trombone, we saw a much bigger gain. But you can see that pretty much every ATCO managed to get 1 or 2 extra flights in per hour, still allowing the departures. We had one who was a particularly good ATCO who did the opposite. Yeah, that's a good skill set. Flight distance savings. So the blue line represents 0. Some of them went a little bit further. Most flights were between 1 and 2 miles better in terms of the distance flown, so 1 or 2 miles less. Ignore the outliers, because in one case, when we ran the ORCI system, the controller forgot to turn the first flight, and so every other flight got a knock-on effect. So these outliers at the end, just ignore. But essentially, you can see that it's pretty centered, slightly left of the 0 mark, and with an average around about 2 nautical miles gain per arrival, which is actually a very, very good statistic. And as well, when we asked them all the post questionnaire workload things, all ATCO said that their task was more easy to do with the tool in place than without. And pretty much everybody in Portugal scored 4.5 or 5 out of 5 in terms of how the tool helped them, how easy it was to use, whether the predictability was acceptable, if the target aircraft were easy to identify. But as you saw on the video, they flash in blue, so it's impossible to not know which is the pair. And that it totally supports their task performance. We got like 4.85 out of 5 for the task performance from the ATCO. So summarizing those results, we saw 39% improvement across the board for the spacing, actually, the target spacing at PESEX for Lisbon, across all of the ATCOs. We got a 3% increase in runway throughput, so 1 out of 29, approximately a third, 3%, 3%, not 1/3. So. For the operational efficiency, we saw a 3.4% reduction in the miles flown in the TMA system, which was equivalent to around about 21 kilograms per flight. We used our own fuel burn models based on BARDA, TEM, Boeing fuel burn method, etc. and the engine database from EASA. And we got a very high controller workload acceptance, reduction in the workload and stress of around about 15.8%. And we had no reduction in separation issues. And in fact, we didn't even ask the controllers to do the fine tuning, and nearly all of the flights landed with the required separation without really any interaction from the controllers after the point merge. Of course, there would have been some slight adjustments, but we saw that there wasn't any much need there. And just for comparison, oh, I did it again. We added the Barcelona. So Barcelona uses the trombone system. So where you turn downwind, you fly outbound, you do your 180-degree turn, not a 90-degree turn, then you fly back in and you're on the extended ILS and intercept and land. But we can see that we got a 57% increase in the spacing improvement for the trombone system, which is phenomenal. We also had an increase between 4 and 12% in different scenarios in the arrival throughput, which represents between 1 and 3 flights per hour, as Jem was saying earlier, for Barcelona. We had significantly better reduction in miles flown and reductions in fuel burn, which is obvious because if I fail to make my turn and I go half a mile too far downwind, by the time I've turned around, I've still got that half a mile to go the other way. So it makes sense that the error is, quote, doubled, and we can see pretty much it is. We had the same, exactly the same result from Barcelona, 15.8%, and no separation issues. So with that, I think that concludes our presentation, and we're happy afterwards to have questions with the Frequentis team.
Next one.
Oh yeah, and then just to recognise, thank you, Helio, for your excellent support from Portugal. And we also worked with Enairi in Barcelona, who I don't think anyone's from here today from Enairi, no?
For Enairi, is our representative.
Yeah, okay. And so they gave us the control access, they gave us all of the skill sets, they gave us the data, which is really important for training the tool. Okay, so that concludes. Thanks.
Thank you. You can stay here on the stage. Yeah, if you can stay here on the stage, please, Thomas, please. If you can join us. And yes, the floor is yours if you have any questions.
Good morning. Thanks very much for the presentations. I thought that was really useful. I have a few questions because I found it really interesting, all the presentations. So your distance is at the merge point. You haven't looked at this to the threshold as yet. You're just looking at it to the merge point. Is there anything around the threshold? That's the first thing. The second thing is, how does that differ from a turn to point that the AMAN is doing? What's the difference between something like that? Another question, and I'll come back to these again, is really in mixed mode operations, it's really about time at threshold rather than distance. You know, if it takes 50 seconds for a plane to get off the runway, 10 seconds for a pilot reaction time, 50 seconds to rotate, it's really the time rather than the distance, because distance is impacted when. So is that being looked at? And then the final question, particularly for the system that you're talking about there, where is it appearing? Is it on the AMAN that this information is being given? Is it on some other screen? Is it on the radar screen itself that the controller is getting the information on? Sorry, that's another question.
I can address all four of those very quickly. The very first question we got asked by Helio and his team was, can you do it at the threshold? So we did some experiments with them, not as part of the actual task, but you guys went in and did some additional experiments where they tried to do the distance at threshold. And the second question they asked was, can you change it to time? So yes, they retrained the tool to provide times at PESX, times at threshold. And we did additional experiments there. Helio can probably tell you more, but you were also involved, so you can probably tell more on that as well.
Yes.
So yes is the answer to both.
We were more conservative in that way, so we can calibrate the tool. So we found accuracy of plus minus 20 seconds at threshold, but we want to be in the -20. So we calibrated the tool to be from 0 to +40 seconds in order that to avoid go around. Regarding your question about if the tool takes into account the departure, time of arrival, and the reaction in so I think that the executive control in the point merge is not thinking so much on that. So it's thinking in, I want to achieve or a nautical miles an intermediate spacing. I think that they are not thinking in the threshold, and if they are thinking, they can just check the figure. But I don't think that the executive controller is thinking if the reaction of the departure in the runway, he has to discount that point. I think that in some way they generalize a little bit more to make the decision.
Rather than saying, you're looking for 6 miles at the threshold, so you're going to get 9. I think what you're saying is you're basing on 9 miles at the merge point to get 6 miles at the threshold. But really, what's critical is is the spacing in times at the threshold rather than distance, and that's where you get your runway capacity.
So as Chairman said, they retrained the tool to predict time at threshold, because that was at the request of the Nav Portugal team, and we did some additional experiments with Helio for that. We also did time at PESEX as well. The third question.
How does it differ from
So how's it different from the AMAN? So we used a pseudo AMAN to get the order of the flights, and that gave us the pairing. The way it differs from telling you when you should turn is that it only tells you if you start the turn instruction now, this is what you will achieve down there, okay? And it leaves the controller fully in control of when they want to make that decision. And if something suddenly changes for some reason, so for example, there's an aircraft that didn't take off quick enough, they can leave it going around a little bit more and move from 9 to 9.2 or 9.3 because it's continuously predicting. And as soon as they've made the turn, then they will potentially use fine tuning to bring it closer again because it managed to get off the ground, or reduce it a little bit further, or do nothing because it's going to arrive at exactly the time we need it. Yeah. So that's the slight difference.
The difference,
but it's fully complementary to what they're doing.
The user. So the user of ORC is the final executive controller, and the user of AMAN is the previous or even the third previous sector managing time to lose, etc. And one question is where in the flight level? The ORC figure is in the controller working position in the flight level, but this is an exploratory research. So finally, after working on that, is better up in the upside of this is something to be discussed. It was less important from our perspective in the exploratory research, but originally in that controller working position.
And to just expand a little bit technically on that, ORC is an on-demand service. So it does not need to be integrated into the AMAN. It does not need to be integrated even into the FDP. It can take data which is published to it, and it responds with a reply. So if I send the data to it and it can't make the estimation, it says not a number. As soon as the configuration is suitable, it starts replying with the prediction if I start the turn instruction now. And it can be, you can subscribe to Ask Portugal and you're on a point merge. You can subscribe and say I'm Barcelona, you're on a trombone. The tool itself will just reply, and it can run anywhere you want because it's a service-based solution, not a homogeneous inbuilt solution.
And if I may just, if I just may, and I fully agree with you, it's really complementary. So for the AMAN, we really focus more and more now, even more than we did before, on the planning tool, and this is definitely, it may be the better, and I like that, maybe the better way of giving some guidance to the controller when to actually turn, but it's a different way of doing that. And of course, it's also using, with machine learning, using data, a different way of doing it, because the AMAN is very much focused on prediction based on algorithm, flight dynamics, and those kind of things, a different way. And I think that's fully complementary and needs maybe definitely both. So, but the planning part, it's like when what is TBO? TBO means we're not managing the traffic based on where the traffic is, but managing the traffic where we know the traffic will be. And that's the part that the AMN provides. It already predicts where it will be in the future, and you have a maybe better but more precise way of managing the traffic based on where it actually is, including the one that lands before.
Yeah, and to build on that, the fact that this was a machine learning based solution, it learned how different airlines actually fly these approaches. And I remember one of the controllers speaking with Helio during the validation and saying, this one turned early, typical, these Americans, they always do that. They flip it left quick, and the two of them were chatting about it, and sure enough, that happened, yeah. So, and the prediction was still on mark. So it learns not only the system, but it also learns the behavior of the airlines using that system, the different pilots, the way they behave, etc. Yeah. And I remember that conversation was pretty good, actually.
By the way, thank you for the 4 questions, because these were the 4 questions that I also on the test.
Perfect. Okay, do we have any more questions?
Thank you, Ian. I'm not going to make any questions, just to complement from my side. I think my first observation is that the comparison between Lisbon and Barcelona, it really highlights the potential the point merge gives in terms of efficiency. We see the same tool working in 2 different types of approaches, and we have a lower result in Lisbon because of the point merge already delivering more preciseness, and that's why it means so much for us. Second, we trained this with the early point merge data. So we had a lot of traffic flying, a lot of points in the arc, but actually it was good. It made us a stress test to the point merge itself and to this really tool. As a controller, and I think you were very technical on that, I would just like to highlight, we did this, the previous and the after scenery, without speed control. So we were achieving great results without speed control, only one communication. Turn right or turn left, direct as X, this in 2000 feet, can H X. And it was it, just that. No further cognitive thinking, no further guessing, no further, well, how does this aircraft behaves? This is an heavy, this is light, this is, well, light, no, we didn't have light. But that kind of preciseness we need to put into our craft, that is to understand how different airlines, they turn fast, they turn later. The machine learning got it all. And got it all right at first, and it impressed me so much. And that's why I believe so much in this project and this kind of development, because it brings down all the inefficiencies, those decimal miles that we lost here and there. And it was a great experience and great work with you guys. Thank you very much for the work.
Thank you.
Thanks, Helio.
Thank you. Do we have any question? Yes.
So thank you, you three, for this very insightful. So on frequencies side, it's still, I mean, it's real for now, 15 years or a bit more than that. And the question would be, to understand what you're saying, and also what Elio said is, then what's next? And any plan? Are there any plan to go for operation with Orki, and what you proposed?
The thing is that trying to find the space to evolve it in different ATM systems. So we would like to have a conversation with ITEC group, also with Coupan's group, because for us it's a pity that our controllers told us, I want this to tomorrow. And I said, okay, the engine is not so quick in that way. So it should be interesting for all the ENSPs participating in those big consortiums. The tool is extremely easy. It's exploratory research, but we have discovered that it's a quick implementation phase. But depending things are conversations and looking for more evolving validation exercises, thinking in time-based with NAP Portugal, collaboration with airports. So there can be a synergies. You have explained very well. Airport, TMA, departure and arrivals synergy in order to know if there is going to be a departure or not, applying 8 nautical miles of flight. There is an automate exchange of information to help the controller in making that decision. But honestly, the next step is just looking for the space to implement it.
And I may have one idea. So, and you mentioned that, and you said that you provide a service to be included in as part of a new service delivery model. That's the term. And we as Frequentis, we are definitely looking very much into that, how to have the new architecture based on the architecture study with a platform and then different services to be applied to that. Of course, it's still some way to go, but we made some good progress with a project with DFS where we use their platform and both Frequentis and DFS services on a common platform. So there's definitely some progress. And then since I clearly see that it's complementary, and I'll be interested in the feedback from the ANSP to say, would that be an interesting way of presenting the turn to point? I think it should be, and it is. Let's explore how we may use that in the future.
Right. Yeah, and just to add to that, I had some discussions with the technical team in Lisbon last week at the Airspace World from Frequentis. They have an experimental system called Mosaics, which is a service-based ATM, ATC system with a series of ATC services. It's experimental for now, and it's the one you're doing with DFS. Yeah? And
yes, it's not. I wouldn't call it experimental. It's really, it's really deployed with DFS, but it gives a lot of opportunities because also that was my impression in the airspace world. Many people are talking about the technology, and there's a strong focus on technology in our industry, of course. But we also, I'm very interested in how we use that technology to give some real operational functions, and that could be one of the examples.
Exactly. So one of the things we want to try and do is to demonstrate to Cesar how you can have a third-party vendor service integrated into an existing flight data processing system that is also service-oriented. We can't do that today with iTech. We can't do that today with the Thales system, with ForeFlight, with Top Flight, because they are closed systems at the moment. But as soon as they become more open and service-oriented, then solutions like this can be deployed more rapidly, can be tested more rapidly, can be upgraded more rapidly. And that's the whole principle of SDM.
Thank you, Karim.
Thank you. Do we have any more questions?
Thank you, David from TAP. I would like to know about the AMAN. Is it working with real data, that is real flight data, or is it also taking into account the flight plan? Because you mentioned FFIs, so I think it's related within enhanced flight plan. Is it also using or plan to use the flight planning information?
No, it's definitely AMAN uses both flight plan information and track data. So it's always a combination, and with FFIs, with better flight plan information being available, that will of course also improve the prediction of the AMAN itself for flights further out. But it's always, AMAN only works if it's a combination of flight plan and track data.
Thank you.
Okay. Any more questions here in the audience? Oh, here we go.
I'm not a non-believer by any means here, but I'm going to ask this question anyway. Does this, if this is working, which is very impressive, and all the rest of it, as is the AMAN as well. Sorry, controller assistance. Okay. I'm concerned. Does the system, if it was working and passes all the tests and gets into the commercial market or gets into operation, would that enhance personnel performance, or are they just going to be reading out what it says? Does it need personal expertise and skill anymore?
Yeah, that's a fantastic question. We had this discussion after every single exercise with both the people in Barcelona and the people in Portugal. And we expressly, and Gemma has expressly said every single time, this is not doing your job for you. This is helping you do your job. So we had the discussion, am I going to lose my skills? Am I going to be replaced, etc.? Some of the Spanish said, oh, maybe I can quit now because this will do my job for me. And in Portugal, it was more along the lines of, no, actually, this makes my job more fun. I can get more traffic in. And of course, it's not going to replace me. And I can almost do as well, as you saw from the charts. Yeah. The guys in Portugal were really, really accurate already. Yeah? Because they had a bunch of little things that helped, like the concentric circles, the distance to each flight, the distance to PESEX. They could click on and off. So they knew how to control this traffic. And even though it was extremely heavy traffic, they performed extremely well. They actually were achieving 28 in the baseline when with a declared capacity of 23 arrivals. So pretty good. Yeah. Although they got one extra flight, 2 extra flights as well. Yeah. So it's not a question of replacing them in our sense. Yeah. It's supporting them. Yeah. Does the Arman replace them? I think the Arman helps them do their job better as well, but the experts in Arman are Frequentis, not us.
Yeah, so I think it's a very big question. For the AMAN part for our tools, the fundamental answer is that AMAN as such is a coordination tool. In principle, it helps to take better decisions based on the opportunity to take coordinated decisions. So that means that whatever the ACC does is in compliance with what the airport, the approach and tower needs. It's the better planning based on the ACC slows down the aircraft because there's a capacity shortfall at the airport. So it's allowing the ATC to take better decisions based on more and coordinated information. That's the general principle of what the AMAN does, and that the potential will, of course, be further utilized in the future when it's also about taking pilots, airlines requirements into that decision-making process, that also the ATC controller may get information which helps him to even better understand what is actually the optimal trajectory. That's the mindset. So it's giving additional information to take better better decisions.
Anyway, your question cannot be ignored. So it's important what you are saying. So ATM community has to be careful and to react with all automations. So we have perhaps to plan training refresh to avoid the skilling. For me, your question cannot be just put apart and automation is welcome. No, I think that we have to find a balance. They are safety assessment and to try to avoid the skilling that you are mentioning. We have to find a way.
Yeah, thanks for all your answers there. It reminds me of 30 years ago when I started in ATM research, the FAR project. And as the approach coordinator in Amsterdam, I didn't have to know what was going on. I just moved a green or a red or a yellow bubble around the screen to fit into the sequence. That's what I'm more worried about, is the fact that it didn't need a controller to do it. It could have been anybody. And I'm a bit heartened from what you said there. So that's good.
Okay, thank you. We have time for last question. If anybody has one more question online, everything okay? All right. With that, please help me to clap for our presenters. Thank you very much. And now let's have a quick break. Let's be back at 10:30, so in about 18 to 20 minutes. Thank you. Hello, everybody. Welcome back. Please take your seats if you can. And we'll jump right into the next segment, where our colleagues from EUROCONTROL and the Point Merge team will be showing you more about what we are thinking about at the moment, what we are exploring, and what are the future concepts and potential improvements and next versions of Point Merge are. And with that, please help me welcome Karim Zegalbek on the stage, who would be talking about Point Merge versions 1.5 and 2.0.
Thank you. Can you hear me well? So we say this solution, it could be something we put on the table. We're not saying it's the only one solution. There could be other ideas. So these are the two sort of recurrent comments, criticism we got from the start. That point merge requires a lot of space, and a point merge generates a long level off. So indeed, it takes a bit of time for us to accept these criticisms. We're a bit in a denial situation for some time, for some years. So, and sorry, I apologize. So we took the liberty to consider the blend as an illustration, and it doesn't mean there's any endorsement from the blend people. So, are the level off necessary? And this is, you see here, we have a sort of, so it's before the two runways operation. So it's a track with high traffic situation on one side. It was the stacks and so on. We know the situation has improved since, but it's really notional. We have the situation here with the double and point merge with the stacks and all, you know, with the arcs with a very strong overlapping. So here, obviously, as you may have seen yesterday, for those who are on site, this means level off. Okay, so it could be a quite long level off, 7.0 and 8.0. And on the right, what you see is a sort of off-peak situation when, let's say, it's almost, I mean, we are reaching the middle of the legs, and there's no stack, middle of the legs, so please disregard some. We are going a bit further than that. So here, the question is really, do we require level off? We need, I mean, the level off is to ensure separation for the two flows when they are coming, crossing. And here, on this arcs here, there was other flights coming, but we know that some or most of them would not go beyond the middle line. So do we need to have level off at least on the initial part of it? So let's now imagine that you just keep the peak figure. We are just on this side. It's a new situation. I'm showing you just a new airspace, a new TMA with just this situation. And the question in this here is, what would you do in terms of procedure? So let's imagine, and again, please apologize, we took the liberty, no endorsement from the blend people. What would you do in that case? In fact, you know, your traffic, that's the maximum traffic, there is no big so on, that's your traffic. So you would design something maybe like this. So you have the initial segment, and actually the legs would not go much further away than that. Obviously, we're not specifying whether it's a flyby, flyover, okay, but we would have something like this. And obviously, there's no lateral separation. So we need to provide a lateral separation of the last segment. So no discussion about that. So 7.0, 8.0, actually like today. And then what do we do on these points here? we can say, okay, we leave you flying as you would like. The point is, 8.0 is actually the maximum, which was calculated, the maximum possible, otherwise you're too high. So if you just leave your constraint like this, most of the time, or some significant part of the time, you'll be flying too high. So I think that's not the intention here. So we need to set constraints here, not for separation purposes, but to make sure that you will not be flying too high. If you're flying direct, flying here, or flying with these points. So now it comes with the question on, can we predict, would we go direct this point? Are we staying on this segment? Do we go on this one or on the next one? But that's basically the point, is here we introduce a notion of liftable, I don't know if it's purely English or Irish, liftable versus non-liftable constraints. So the red one, you would not touch these constraints, therefore separation, they will remain. The green one are to ensure we're not too high, and this one to be lifted depending on the traffic, depending on the predicted elongation. Then there have been questions, there could be some possible limitation, but to be discussed. But that's really the principle. Now we introduce liftable versus non-liftable. And actually, that's the real one, or almost the real one. So we have 7, 8, and that would be sort of the two set of stars, peak and off-peak. And again, and we have been discussing the question of any issue regarding the switch between transition and so on. And here we have our safety specialist, and I know that Bruno Rabillet would not let us do any creditings for that. So we need to go further and investigate with you any issues. But that's really the key points. And actually, now we have some typical situations, and this is again, sorry for those who are online, you have on site, sorry, you have seen this yesterday on the generic airspace. So here we would assume that Thomas would provide a sort of turn to point, as you may have seen. Again, the point is not to have a precise indication of where to turn. So this could be useful, as we discussed, and as we discussed also with Orki. So that's another question. Here we need an indication which is roughly where on the segment, what segment or which segment will be flying. So typically we say roughly on this one, there's nothing we can lift, otherwise there is a risk that we would be too high. If we predict we'll be roughly on the second segment, we can lift this one, but we may not lift this one. And if we go on the third one, then I would say we are protected by this, so we may lift this one, then this one. Okay, so that's really, it's as simple as that. We don't need a lot of accuracy, just roughly on which segment we'll be going. And just again, and here that's a real name, Sorin, Sivna. Actually, so these are pronounceable name. This one, the real one, is Shugad. And here we may turn it as a non-pronounceable name. So you're not supposed to lift these constraints. So it could be also something in terms of awareness. We're not touching any of this. So that's really the principle. And we play with the cockpit with this procedure modifier, so we are able to put them. So we are playing on one scenario, which is going almost full leg. This is a sort of baseline scenario, and you see here the level of vertical profile and the cumulative flow. So we go quite almost an idle descent, then the level off on the legs, and then again the descent. And now we would assume that we would lift the constraints. So here I think we were assuming something a bit more like 6 minutes ahead. So 6 minutes we would lift the constraints, Sorin, then Sivna. And then it's the same elongation. So it's the same elongation, just playing differently with the vertical dimension. And here what you say is, okay, initially because it was a 6 minutes look ahead. We're on the profile, then we lift the constraint. So then we are below the vertical profile. So this is what you see on the vertical profile. There is a sort of regaining, so a bit more fuel burn, just regaining the profile, rejoining the vertical profile. So there is a bit of a cost here, but then which is compensated or more than compensated by actually a quite small level off compared to what we have over there. So on this typical flight, it's a 320 on the cockpit. So we have a gain of more than 20 kilo on this specific flight. Then it depends. If you go direct, there wouldn't be any difference. So then the question, it's very much open. So here we have developed a tool here to help defining, and then it's very much up to the up to the ops people to decide that there's a notion of trade-off, which is where do I set my threshold between peak and off-peak. So here it's purely arbitrary. We say we go for the middle because it's more intuitive, but it has to be the result of a trade-off analysis. So we say it's a sort of more or less 5 minutes. So we have the trade-off. We see how far we go on the legs. And then the question behind, it's really, this is on a typical day, a recorded, it's not prediction, recorded information. And here we say we have here what we call the this famous additional time, ASMA additional time, which could be, in fact, the time along the leg, or the time flow or the distance flow along the leg. So we have on a typical day, we have, a bar is I think it's a flight or 20 minutes, I don't remember, maybe it's a flight. And actually, here we have the two regimes. And if we set the time to 5 minutes, actually we may start early morning with a sort of off-peak period. And the off-peak, we say that's a maximum. So even if you have low fly, okay, maximum, the max stays below the threshold I've decided. So I consider this one being off-peak. And then it goes up, maybe for 3 flights, but okay, that's a maximum. And then, so it's 1 hour, 2 hours. So here I'm on the peak period. Then it goes back again, down again to 2 hours of peak, and so on and so on. So then there is a real question about, at some point, we want to be, to adapt as much and to be very much reactive, but maybe at some point it doesn't make any sense operationally to switch for 15 minutes. So there is a question here about how many changes do we accept, bearing in mind, obviously, there could be issues with the swapping, there's always risk and so on. So we want to be as flexible as possible, but we have to retain some form of stability. So it's only a matter of trade-off. We are not saying anything here, whether we go for 1 hour, 2 or 3 hours, at least for a switch. And so here it's a sort of, it's from recorded data. In real life, it will be prediction data. So it's a FMP position that would have to, okay, I'm confident that for the next 2 hours, we'll stay off peak. So we can deploy for that. So it's really notional just to see what may be done there. So here, requires a lot of space, generate long level off. So here, let's consider during for off-peak period, we have partly addressed criticism too. So now let's go further. We say let's revisit point merge. So it's ideas to put on the table. I'm not saying this is for tomorrow, even for next year. So please take it as a way, food for thought, and as a way to generate a discussion. So actually, it requires a lot of space. So you may have heard or the trombones, which have been discussed before. So on trombones, so it's Frankfurt. Trombone is a sort of upwind, downwind, and so on. Here we are along this way, Frankfurt. And actually, and that's another point merge. I think it's Istanbul, if I'm correct. And then actually, when you say it takes a lot of space, actually in trombone, it's quite packed. So we have 12 miles, 30 miles, and the extension, just go through, it's 50 miles. In this sort of a pack extension. Compared to point merge, well, Istanbul is quite a big one, but still, for only 30-mile extension, in fact, you take a bit more space. If you want to go for the 50 mile as this one, you have to go for a very big space. So actually, we have to accept that, yes, it takes more space. It takes more space for the same elongation. We have to be clear in what we say. Okay, so then what can we do? And then I'm very happy to say, again, we are just learning from others. And maybe this was the start of it. We never invented something. We just collect things that existed already and just put them together. And here, I'm happy because here, this one, some of you may remember. So we have two Italian colleagues here, and I'm very happy. This one, actually, we had initially 3 pioneers. 2 decided to go, and I would love that we start from Roma as well, from ENAV. We had incredible exchange with Roma, and it was a plan which was tested in the training room at Fiumicino and the design of Point Merge. So there have been, it was really incredible. I go on this one. It was simulation, so unfortunately, never in operation, but I've seen it. First time I've seen it outside Brétigny, it was in Fiumicino. This one, Canary Island, so maybe this, I know if you are part of it, of the design. So Canary Island, it's not a big airport, but it's there have been some issue. You know, there was a summer effect and so on, and they deploy something like this for one of the airports. And this one, we have also people in the room, and maybe the person who designed it. So that's Lisbon, and that's a Lisbon, the simulation. So I took the liberty, hope it's okay with you, not Portugal, we took the liberty to put that. And why that? Actually, there have been some changes, as you may see from Elio on this part. So there's a point merge, and hey, it's straight. It's not like this. And actually, we'll send you the slides. And actually, what we can see here, or what can we see here? So I see some people smiling. So the answer, and we see a sort of, typically it's clear here, we see a sort of point merge, so we see a point merge, and here we have a sort of trombone, which is bended. So here it's clear, it does not cover the full leg, but it's a sort of trombone. Here it's a sort of initial trombone as well. And here it's only one leg. Okay, so then that's a design. The mode of operation is not described here. So we'll have to infer it. And the point is when see this is okay, let's so us, what can we do? So we are on one side a point merge on a trombone, and well, that's when point merge meets trombone or the other way around, is what can we do? And taking the best. So this is what it could look like. So now we have what we have seen on the previous one. It was just one leg, one flow. And actually, it's new in the way that you have two flows, mixing the two flows. The issue, obviously, we have to be extremely careful. So there are many issues. So this is why I'm not saying it's for next week or even next year. So we have to be careful. Here, there are legs that needs to be one above, one below, because it's turning. Normally, here we have no separation issue, and we go and then we descend 5 miles, so it would be okay and so on. But this is what how it could look like. We have to be careful when we descend and so on. Again, there are questions, open question that needs to be addressed. And actually, so we play a bit with it between us. So this is why maybe the difference with the trombones. So on trombones, you would shortcut on the other leg. Here we would let the traffic go along the first, the outer legs, and then we get an additional segment for additional pass extension. So we go like this, then it means that we can go like this. So there could be many questions, but just a sort of ideas we are proposing. And by the way, so we have addressed, or maybe we have addressed criticism number 2. And now is, can we, number one, sorry, and then can we address criticism number two? Number two, which is long level off. So we could address a level off during off-peak. Can we now go and address a level off during peak periods? So for some of you, I mean, you may remember, we have seen before, we have the version 1.5, and the version 1.5 was to reduce overlap. So let's try to do the same. Actually, now we reduce overlap and we have the same principle. And actually what is quite funny is now it's the same elongation. So it's not a question of peak versus off-peak and we reduce. Now it's just a question of we keep the same elongation, but we reduce overlap. So here and here, notionally, it's the same overlap. So again, we play, it's between us, so it's a typical on the generic environment. So it could be one version, what we call it, so the normal or the single point merge, and just going to the double point merge. So we are extremely careful with the separation. So there are separation. It does not mean that we have addressed all the safety issues. We need to address safety issues, in particular in terms of cluttering and so on. It's notional in terms of separation. So from a separation perspective, it seems to be okay. From the full safety study has not been done. Well, this is how it could look like. And again, now we have the same elongation, but a different geometry. So the question is, well, which one would you prefer? And maybe we can discuss. So we play, we did some tests. So typically comparing for the same elongation, and we play the this one. So sorry. So we look at this one, 300 seconds on double point merge. It means something like this, and here the signal like this. And again, we have been playing with the cockpit, and so it's the same. So we have the vertical profile, the cumulated, and the vertical profile with the single. You may anticipate the long level off versus with a double. There is almost no level off. So in total, now we have even a higher gain compared to what we have shown, which is 4320. In this specific, with a longer elongation, I mean, we have this specific potential gain. So finally, again, please allow me to be a bit provocative. Did we address the criticisms? Notionally, maybe it's an open question. So high capacity in a reduced area, we have merged the point merge and the trombones. And excuse me, I miss it. Reduced level off, so we are shown version 1.5, yes, of peak situation, and maybe now, maybe we can go on a systematic basis. And then if we go, but still we have some, we have to be careful because it's not vertically separated. So still we need some vertical restriction, which may or may not meet a level off. But then the full would be, actually it should be a sort of red. If we make sure that there is a lateral separation, then we can have two independent descents. So this one is not easy. We have started addressing, I mean, considering the safety aspect, TCAS aspect, and so on. So it's not for tomorrow, it's not for next year, but just ideas we are putting on the table to generate discussion. So now, I think it was not me, it was Bruno, so Holy Grail, okay, I don't know. But here the point is, we may be able to go for full continuous descent, not only for off-peak, but full continuous descent in high traffic situations. Again, it's provocative, so please allow me to be. And now, when we step back, actually we started with something like this. We say, okay, maybe we can go this way when we reduce the traffic, peak of peak, and so on. But also, we can go from single to double point merge with a full capacity So we're getting very long, long path extension versus something like this. So we don't mean to confuse people. Then it opens up a sort of other potential or possibilities that needs to be addressed. So obviously we would welcome if you see any interest, and with no obligation for sure.
Thank you very much, Karim. Now we continue with Bruno and Claudia, who will tell you a little bit more about, indeed, how can we still innovate with Point Merge.
Good morning, everyone. I'm Bruno Fabenek. I'm working here in Karim's team. I've been lucky enough to witness the birth of Point Merge myself. I'm an engineer by training. Nobody's perfect, but I must say that I had the opportunity here and in other places to work with a lot of controllers and pilots, and they seem to have pardoned my poor education. Welcome, please, also my colleague, Claudia. You can introduce yourself briefly.
As a data scientist here at the EUROCONTROL Innovation Hub, and I've joined Karim and Bruno's team in the last 3 months.
So, Karim actually answered that question, maybe not willingly, but can we still innovate with Point Merge? It seems that we have some ideas. We might have some ideas, right? But if we have those ideas, maybe that's because we can learn from what has been done. Sir Isaac Newton once said, I reckon it's an approximate quote, but I swear I didn't invent it. He said something along the lines of, if I was able to look beyond the horizon, it's because I was sitting on the shoulders of giants, meaning the ones that preceded him. So here, we have to be humble, as Karim said in his introduction speech. We might have had an idea, but now you, who implemented Point Merge, who made it all the way, who had the courage to do so, are the giants. I really am sincere saying that. You know a lot more than we do now about Point Merge, because you did it, you implemented that, you put that in the real world. So we had yesterday a glance at 4 places where Point Merge was implemented. We had some interesting debates on various questions and issues. We had a glance on tools that could be supporting the controllers, future ideas with Karim. Now it's perhaps time to step back and see how we can collectively go further. What can we do to learn from each other and to trigger innovation? For this, allow me a bit of a digression. I will change domain. It's time to step back, take some height. For this, I will summon a mysterious gentleman on stage. I don't know if you know that person. Please welcome Charles Messier on stage. It's a French astronomer from the 18th century. At the time, people had just understood that the Halley's comet was coming back every 76 years. And he was looking for it because it was really trendy to chase comets. Stars were not interesting, planets were already known, but comets, they were announcing the plague, catastrophe, wars, etc. That was a trend. So he was looking for the Halley's comet, but he had a problem. He did a miscalculation, and he was looking at the wrong place. So with his instrument, he saw some nebulous objects that he couldn't easily distinguish from comets. Only by patience, he would find that these objects were fixed in the night sky, unlike comets. So it took time to say, these are not comets. It was really a bother for him. But he was a generous man, so he decided to help his comet chaser colleagues and establish a list of these annoying objects, completely uninteresting, that were not comets. And here came the Messier's catalog of nebulae. By the way, he discovered during his life about 20 comets, or co-discovered them, but he established a list of 103 objects. non-interesting objects, not comets. He had no idea, even after he died, he had no idea until the end of his life, that doing so, he was actually laying the foundations for modern astronomy, helping us understand the universe in its diversity. He saw these objects, he had no idea what they were. He discarded them as not interesting, but he classified them. He positioned them in the sky. And today it's still used by amateur astronomers. We even have a uniform scale representation of objects to find them easily in the sky. So I will ask you to keep this in mind. Classification, charting, uniform scale. Addressing diversity, observing. Now let's go back to point merge. 15 years of point merge deployment. Initially, we were lucky to have deployments close to us in Europe. And then with time, we were doing some web intelligence and discovered that it was rapidly spreading outside the ECAC area, beyond our remit, beyond our horizon. So we decided maybe it's good to take our telescope and start looking at what's happening elsewhere. We started using official publications, looking on the web, but then we decided to look at tracks because we have ADS-B tracks from all over the world, and also implement an automated detection of point merge using very simple geometric criteria. We came up with some interesting discoveries. Still, we had a lot of false positives, false negatives, because what you're seeing with the tracks is the operation. The procedure may not be followed at all time. So later on, we realized that in this cockpit, as Karim said, we have a worldwide database of navigation. And we could explore that database because looking at the publication is exactly what we want to do. And we can detect easily with the same geometric criteria where we have point merge implemented. So this was just to detect and put points on the map. But then the importance of observation. To go further, could we analyze and learn from those now 61 implementations? Where we started, we had a look. This is how we thought point merge would be implemented. A very simple design, as you see, a very simple sequence of actions. And this is how, what we can see with the tracks, how it's operated, actually. What do the tracks tell us as part of, well, we can see that it can be a simple idea, but in the end, there are not so simple bits when you look at the details. So what do the tracks tell us in terms of, for instance, adherence and perhaps further regimes, operational use? Also, this is what we thought designs would look like. Initially, a very simple idea, for sure. We thought there could be some variations, depending on the number of entry points, runways, and so on. And then this is what designs actually look like. Oh, wait a minute. Okay, what do you see here? It's difficult. Well, not so simple bits of a simple ID part 2. We have the same simple principle, but there are a lot of variations, a very significant diversity. What can we do to address that, to find order, and to try and feedback our stakeholders with what we see? We actually started exploring the designs and the tracks, and I will leave the floor to Claudia to show you how. Yes. Some of you already saw part of the demonstrations yesterday evening, but I think it's worth looking at it from the perspective of what I just said, and also for those online who didn't have the chance to attend the demonstrations.
Yes, thank you, Bruno. So my role within the team was to help well, to support them to visualize flown flight trajectories and point merge procedures, with the goal of creating a catalog of a publicly accessible catalog with all of them that can be used by both ANSPs that would like to implement point merge to get inspired by the different implementations worldwide, but to also support in innovation for ANSPs that already have point merge implemented. And in order to do that, we built 2 dashboards within the team. One was built by my colleague, Enrique, who is sitting there. And okay. My Alt tab skills were working perfectly this morning. I don't know what happened. Okay, this is the dashboard that is publicly available on Tableau. What it's showing you is the worldwide availability of point merge procedures. You also have some statistics on the characteristics of the point merge design. Here at the bottom, you have the distance to the merge point versus the length. And once you click on an airport, you will be able to dig deeper into the data. And take a look at exactly the procedure, see which procedure is being used on which runway. And the second dashboard, I built it myself, and it's supposed to give you a feeling of how the data is being used, well, how the flights are being flown in practice compared to the procedure. So if I take the exact same airport, you will be able to see the tracks displayed alongside the procedures. We should also be able to filter out the information based on the runway that is of interest to you, based on the exact procedure, and also based on the flow, so where the traffic is coming from into the airport. And you would also be able to hide the procedures if you just want to investigate. This dashboard is a prototype, and it serves as a basis for further analysis of how point merge procedures are used worldwide. The first dashboard that I showed is public, and this one is currently an internal tool that we're hoping to get feedback from the community on how we can further develop it. Thank you.
Thanks, Claudia. I will, can you hear me? Yeah. We'll go back to the presentation. Thanks. Thanks a lot. So we have seen what we can explore. Now the question is, how can we sit on your shoulders and go beyond? How can we use all this useful information? And someone asked us actually yesterday, do you have a catalog of point merge? Well, we don't have it yet, but it's being prepared. So we can do like Mr. Messier did, or his followers, a classification. We could use the purpose of the point merge implementation. Is it for final sequencing? Is it for pre-sequencing? Is it a point merge followed by a point merge? We can look at the dimensions. We can look at how it is constructed, 2 merge points for one runway, 1 merge point, how we join the point merge, the legs, how we join the runways from the merge point, where it is positioned in the TMA. We could also then explore more dynamically the tracks and the procedures themselves. And we could even have a uniform scale representation to have a national idea of how it is all made and how it can be classified. It looks very much like the Messier catalog and how it was done. And that's perhaps the backbone or something that we can use to share information, to learn from others, and to progress. We have these statistics showing on the x-axis the average distance to the merge point for each site. On the y-axis, the average length of the sequencing legs, for instance. You can try and cluster this. You've got small dimensions, medium, large dimensions, very large dimension when it's a point merge system in the ACC and stuff like that. You want to build a very small point merge system. You don't know what's the minimum size. Well, we have 10 nautical miles from the legs to the merge point in stock for you. The average one is about 18 nautical miles for 24 miles on the sequencing leg path extension. And the largest one, for the time being, that we documented is 50 nautical mile path extension, 20 nautical miles from the legs to the merge point. You are looking to a very large one in the ACC. This is in China, feeding 2 TMAs. You want to have one leg, it exists. It's there, and it's used. Actually, we have the tracks. It's perhaps a way to have a dog leg with more accuracy. You want two sequencing legs. It does exist as well, of course. 3, they do exist also. We didn't see 4. Nobody dared to go beyond 3. How many merge points for runway? We have 1 and 2. We don't have more, but it's maybe sufficient. How many runway can you feed with a point merge system? 1, 2, 3, more. It does exist. Istanbul has triple simultaneous approaches, and they are feeding this with point merge. You want to use point merge for pre-sequencing, followed by a smaller point merge for final sequencing. It does exist in at least 3 or 4 locations. You need pre-sequencing with a different technique with dog legs. It does exist. This is Istanbul. You want dissociated sequencing legs? It does exist in Dublin and other places. You have a multiplex and you're wondering what you could do about that. You've got a very constrained airspace, 2 close airports, 2 close major airports. Maybe point merge is offering you the possibility to locate your point merge system in a certain manner, to tilt it, to position it, compared to trombones, for instance, where you are more dependent on the runway axis. So this is Istanbul. You can see here in blue and light blue, that's the big airport. In green, it's Sabiha Gökçen. Mexico here, you've got Mexico City here, you've got a mountain there, and you've got Toluca on the other side. Here you've got Tokyo with Narita and Haneda, very compact, tilted, but it's used. You are wondering whether some countries have come up with homogeneous implementations. Well, look at Norway. In Norway, yeah, you did something very interesting. For at least 3 of the airports, you did a very homogeneous design, and it's really logical, and it looks like it's adapted to your conditions. It's interesting to see that, these common features in a single country. In Japan, you have very interesting things with 2 different point merge systems slightly displaced, feeding 2 runway orientations, and each time it's with 3 sequencing legs. That's Fukuoka and Osaka. Again, common features. So there are plenty of examples of what can be done. We can go on like that for quite some time. You have got some implementations with runway and invariance, the same point merge system feeding the same runway on both ends. Or alternate systems. This is Kuala Lumpur, where they have a lot of weather issues. Sometimes they have to change the point merge systems from the blue system here to the green and the rose one. You have seen, again in Norway, mixing point merge operations with RNPIR for shortcuts on the domain. So lots of options, a lot of things that we can catalog, a lot of things that we can use to learn from each other, to feed all this in common. We have an inventory of possible options for the design. We can look at procedures versus tracks in terms of, as I said, usage, adherence, upstream adherence before the sequencing legs, downstream adherence towards merge point and beyond. It's only one part. We shall go beyond. We shall look at the departures, options for departures. What happens on the vertical dimension? Maybe dynamically. How is it used to build a sequence? We can also want to link to performance indicators and stuff like that. So it's a very rich information. It's a very rich source of data that can be shared. And we can augment it with your experience, with the issues you encountered. So that's what I debated yesterday, for instance. We can feed all together a kind of repository to share information and go beyond. And that's not all. It's not only looking at what exists and provide a catalog for the newcomers. It's also, as Karim said, feeding innovation with new ideas that we can find in that catalog in what you did, using the same design options in different contexts for innovation. So a catalog may contain the figments of these further innovations. We may be able, we have the opportunity, the power to trigger these innovations together. How do we do that? That's what we will see after the break with the next slide. And that's the end.
Thank you. Thank you, Claudia, Bruno. Claudia, if you can come back to the stage, and Karim as well. And now we have 2 minutes to ask questions, if you have any questions or comments. Okay.
Thank you very much. I have one question, because a topic that frequently comes up from our customers to us is how can we maybe in the future allow to change, to optimize the sequence? Maybe a flight is already very important for an airline. How can we have procedures in the air that allows ATC to take them first to the sequence and delay a flight which may not be that critical at the second position? Of course, it's not easy in the airspace to allow for kind of overtaking in the sequence. Do you consider that in the design of a potential future point merge system to provide a bit more flexibility for ATC to further optimize the sequence, of course, without safety, that's clear, but also without a negative effect on capacity, which is, of course, always the issue?
From my understanding, maybe limited, it's not a black and white situation, it's a trade-off. With point merge, the design offers you some trade-offs. If you have long legs, you've got large capacity. If you've got a long distance between the legs and the merge point, you have more space for CDO, version 1. But the longer your distance between the legs and the merge point, the lower your flexibility to adapt the sequence. So it's really a matter of priorities, local priorities, indeed, and it may be addressed that way, I believe.
So it's two-dimensional, actually. So as Bruno say, it's very much scalable. So you see all this design, which is quite incredible. I mean, we started with some, our limited brain, a limited horizon, and then we see all this design. We wouldn't thought about that. So that's the first aspect, which is the way you scale your system and you put your trade-off and so on. So that's one dimension. The other dimension is what we suggest before with this peak of peak, which is actually if you go for peak of peak, well, we can think about 3 or 4, but then it's not credible. So maybe let's just stay with peak of peak. Already there could be some issues. Then you have a way to dynamically adapt also your trade-off. So you can scale your trade-off on a fixed basis, I would say, but also you may adapt it depending on the time of the day. Again, we are not talking about switching every 15 minutes. So there should be some sort of stability, but then we can think of this second level of adaptability. And then this is where, I mean, you may answer that we need some prediction tool. We have seen a prediction with a I mean, this sort of 5 minutes or 10 minutes to get to lift constraints, but we may need also a prediction with a larger look ahead to switch or switch between configuration. But this question of the dynamic adaptation is not specific to point merge. You can think of playing with different. What is specific is the way you adapt actually point merge, as Bruno said, with the fact that you explicit the trade-off by the way you design it, your system.
Thank you. No, I was just thinking about it because of point merge, of course, the key benefit of point merge is that from each of the point on the arc, you have the same distance to the runway. Right. So that allows you to maybe let the aircraft which is further on the arc to turn later than the aircraft which is early on the arc in order to allow that overtaking. I'm not a ATC controller, also not a procedure designer, but I'm looking for ways to leverage the opportunities of AMAN to predict and optimize. But of course, it needs to be supported by procedure design to allow for this optimization.
So then it really depends the way it's being operated, also on the TMA, and also there have been, and here it's Claude operating on the Paris ACC, and also the point merge, and we might discuss with Claude later. Point merge was always also to support a swapping of the flights. So the TMA, typically you have the consideration of the wake. So you would try as much as you can to group a bit. We're not talking about a pack of 10 heavies, and then, but you may swap a bit to gain in terms of capacity. But it's something which is offered as well by the point merge. It leaves, I mean, a bit less workload, and you may have the possibility. It was the case. Again, it depends. If you have the two arcs, you may swap a bit. Then if you complete swap, it may be a bit less easy. Yeah? So we have to remain. Thank you.
Hello, Marc Azoulay from Paris ACC as well. So very interesting what you are saying. So on the dynamicity, sorry, of the point merge, I think it's very important. In the future, it can be a possibility to help predict the pilots for their descent, to optimize the descent, and for the controllers also to be able to know, to have a link with the AMAN and to give the appropriate point merge and the number of legs they will be flying actually to meet the AMAN requirement for the delay absorption. So that's something that can be interesting in the future. And also regarding the dashboard as well, I think it's very interesting for the ADSB tracks. And so we'll be very interested in having access to that as well. You said it was internal for now, but definitely in Paris, we don't have access to this kind of statistics. So it can be very interesting and useful for us. Thank you.
Just a word on the what Claudia showed on the tracks. So we have an agreement with our colleagues from Flight Radar 24. So we have to figure out whether it allows us to go a bit beyond. So we have to discuss with Radar 24. There is a value, and I think they have an interest. I mean, they are involved. They know what they are doing. They publish paper on pointer as well. So then we have to discuss with them how we can together go further without, I mean, giving the impression to compete. From the procedure, it's available online. So you can get the procedure. It was extracted from NavDB, from Jepsen, and we buy one every year. We have a special price. Every year, ideally it would be every year Iraq cycle, but it's a bit costly still. So this one is available online for the tracks and the combination. Claudia showed the combination of the tracks also with an overlay of the procedure. For this, we would have to maybe to wait a bit. Merci, Marc.
It's not a question for Claudia, but maybe a suggestion. I agree with the French colleague here that having public access to the prototype dashboard with the traffic data would be really helpful. And I think if you could expand it with a layer with some sort of performance monitoring, then you can start looking around on different implementations of the point merge system and see what type of performance do they actually achieve by doing this compared to this. You can add filtering data on specific types of performance just to see if you can get benefit from one design compared to another design. And then, of course, in addition, it could be interesting to have some sort of baseline data on other systems as well, trombone systems or open loop star systems, and try to see if you can have a comparison on data before and after implementation when you do new implementations, and do a historical archive. That will be on my wish list for Claudia for the publishment of the dashboard.
That's a long wish list, but thank you for all your suggestions. In any case, they're really helpful, and this is the kind of feedback that we were looking for to get from the community for the dashboard to expand it and to grow it further. So we'll note all of this down.
And by the way, so before we go for the full, as you ask, we already have a dashboard for the top 30 in Europe, where we have, I mean, your Dublin, Lisbon, and Istanbul, Sebiago chain. So at least we have 5 already part of the dashboard, and the 25 not point merge. So at least you can see aspect of it. In the data, we show also, so we show a lot of data. So we work with Sarah from the PRU. The point was at some point that is being hosted by the PRU more officially, and to complement actually their dashboard and on NS performance, which is a more official one. On that, so you have the metrics, and also you can visualize the tracks and profile, and already, so it's not a metric, but already it tells you something. And I would like also to discuss with our colleague from PANSA. So we have Varsovia in it to know about profile. You can see the profile, and you can compare the profile with the profile at Oslo and profile at Dublin, Lisbon, and Istanbul. And also you can, so the point merge profile, I would say, versus trombone-like profile, and also we have our colleagues from NATS, and you can see also the effect of a profile when you have a NATS type of procedure, which is a CDO distance to go base, and it's quite amazing. Actually, you can see even if, beyond metrics, you can see just at the profile. You can, even if you don't, I mean, we don't put the name, you can infer the profile what is behind. So it's quite amazing. I mean, just looking that you can infer things. Actually. So we hope that we are going to show you. So it's empiric, and we'll develop that.
Thank you. Next question. If there is any, if anybody wants to add to the wish list, sounds like a nice Christmas wish list. Just don't know which year.
Thank you. Chris Shaw from EUROCONTROL. Thanks for the great presentation, Karen, Bruno, Claudia. Yeah, it's always been a puzzle to me why, from the map that you display, Bruno, why North America has nothing. And I just wondered if it could be to do with the difference between public and private sector ANSPs, if you'd noticed anything like that in the data that you've seen the rest of the world. Maybe the private sector is quicker to...
Do we want to answer this question?
We actually we didn't try to get an answer from that, because we are not in touch with directly sometimes. We know that for Australia, there was a study in Australia, there was a study in Toronto, in Canada, but each time, it's maybe, when they started looking at that, it was too early. You need courage, as Karim said, to opt for something that was not deployed anywhere in the world before, to be a kind of beta tester, first implementer. It's not something that you take easily as a decision. And so you can find all the arguments you want for, noise and stuff like that to decide it's not the good solution. You can also try and dig and understand whether you can have a trade-off, but we don't have the answer in short here.
On this, we can debate a lot about the cultural aspect and so on. So maybe there is a sort of attitude to innovation in Asia compared to other part of the world. So it's one aspect, which is a bit not supported by data. It's another debate. But there is also a question about the expansion. As it was mentioned also by Dublin that at some point, maybe also in certain way with Lisbon and Sao Paulo, at some point you see the traffic demand, the forecast, which is coming, and you say, I will not be able to handle it. And in Asia, it's an order of magnitude higher than when we are here. So that's maybe part of this sort of strategic vision. And actually, if you Google, we have also the plan. So I don't know if they are online people from China. We invited them. Actually, there have been a sort of multi-year plan for China, which was, I think it was almost 5 years. Bruno, I don't remember, to go for point merge. It was a plan. Go for point merge for all the 17 or 16 international airports. So it was a sort of a plan built looking at the traffic forecast. So maybe it's also part of it.
Thank you. Thank you.
Regarding the different layouts that you are trying to innovate, it's like a brainstorming and they should not be criticized. So don't take that comment that I'm going to do as a criticism, just to, as I came from analyzing trombone, this double leg layout is to increase the capacity, I will say, increase the elasticity of the point merge. There will be more flights simultaneously on frequency. So my suggestion is in that way, we will lose again the cognitive units to perform the final spacing. So it will be very similar to trombone, but it's true that it could be better to distinguish between final sector and feeder sector. Perhaps this double leg merge, my suggestion would be that it's a feeder sector purpose, because otherwise you will not be able to pay attention that you need in the final spacing.
So, I mean, we played the exercise to say, we receive criticism, can we offer a 40 miles elongation? Actually, and this is back now to, I mean, that's a reality. So it was a sort of intellectual exercise. Maybe you have something popping up, you're getting at the end. But the point is 40 miles, when we see, and this is what we are looking with Sarah from the PRU, we have the statistic about additional time. And do we believe, as part of a TBO, AMAN, stuff like that operation, do we still believe we need 40 miles elongation to an airport? So there is an AMAN, which is the first layer, first filter to stream the traffic out. So what would you allocate in AMAN? And then maybe then, and this is what's being shown yesterday by Raphael, so even go on the ground. So maybe the future is not to provide a system with even 50 miles elongation, and you have to pay the price in terms of fuel and CO2. Maybe the point is to find the right balance, the right allocation of delay with a sort of final sequencing, initial streaming with AMAN, some extended AMAN, and then on the ground. So maybe what I'm saying is just obvious, but we have to keep this in mind, and people tend to say, yes, but I need 40 miles elongation, full stop. Okay, so I'm provocative as well. Thank you.
Just to follow what you're saying, that's exactly what we have in Paris. And maybe the extended point merge 1.5, 2.0 is for places where you're unable to absorb delay on the ground. So maybe in Asia, when they maybe not have the ATF system we have in Europe. So in Europe, that's exactly the case what you're describing in Paris. We are looking for the right balance between ground delay, AMAN and XMAN. And so we are working on that, and we're looking forward to have discussions with you about that later. But clearly that is exactly what the objective is, to find the right balance. And that's something that's missing in the dashboard, if I may, that there is no ground delay in the dashboard. So clearly, I think it's a little, it's something is missing in the dashboard with the ground delay.
Just one thing, so it's being also presented by Tom Bod yesterday. So they put a lot on the AMAN and streaming, and then you have less sort of residual delay to keep a bit of pressure on the runway, but in a reasonable manner. So that's one thing. Second thing you say in the dashboard. So if, in terms of metrics, actually it's done by the PRU. And we have the additional time, and if you look at the part which is usually the chapter 5 for TMA airport, I think it was a chapter 5 where you have on the same graph below additional time, which is more the tactical part, and the ATFM delays and so on. And this is also what we are looking at, which is the sort of balance, tactical ATFM, and then you have the AMAN in between. But that interests other issue in relation with the single sky. I mean the performance framework, but that's a sort of political issue we may discuss later.
And if I may add, this balance may be dynamic by nature. You may decide before the day of operation that tomorrow you will have to favor capacity, but you may decide that the next day maybe you can do some effort on fuel efficiency and environment. So you may shift the trade-off. You may balance differently depending on the days.
Okay, I just learned that we have a couple of questions online, so perhaps Americ can help me ask these questions.
Yeah, there's an interesting question. So point merge system implementation shared so far are mostly success stories. Are there any failure case, and what could be the reason and potential way to improve?
There was a case in Germany, Leipzig Halle, where it was implemented. They had a very large design, and then it was initially a single runway operation, if I'm correct, and then they went to parallel operations, and they decided to drop the point merge and to go back to trombones because of this particular feature.
If I may say, also under the responsibility of our Norwegian colleagues, so there have been also a first design initially, and then quickly, if I remember correctly, it was the Hope, it was a second project, the Hope, a new Hope, and then they quickly adapt actually their design. So it was the same principle, but reduced so as to fit the capacity. So it's not a binary yes, no. It was in principle yes, but we need to adapt, and please correct me.
And another question, which is more global for the implementation. So you have presented a lot of different variations, a catalog with 2, 3 legs and so on. Now the question is, if we have to implement a future point merge, should we aim for version 1, 1.5, 2? Are there any airspace that are suitable or not? Any constraints?
Maybe there is a path to implementation. Maybe it's something that has to be gradual.
I think we have the next item with Polar. So we would say, how can we build a community? So we would welcome, I mean, the existing users, but also those who are willing to, or we are considering, ready to join, and we don't have the answer. Maybe the catalog could be a way to help, but we need also operational feedback. So we would, I think maybe it could be a good transition. It's a good transition for the next.
Indeed, it is. And we were just saying because we were checking some other questions there, but I think unfortunately we won't have time to answer all of them. So it's also for the people online, we will get back to you to answer your questions later on separately, and very happy to engage in continuous discussions. But for now, please help me thank our presenters. And let's go again for a quick coffee break until 12 o'clock. We will be back in about 15 minutes. Hello, everyone. Welcome back. Please take your seats again. For the last segment of this event, really looking into what's next and what can we do next together with you, and how we can perhaps create a community, building on what Karim and Bruno and Claudia were saying just before the break. So with that, I leave the floor to Paula, who will be guiding us through the session.
Because please don't clap, because when I arrived this morning, I saw one of your colleagues in the breakfast, and I asked him, you know, small chat. So how is it? Are you enjoying the event? And he looked at me super serious and he said, yesterday was brilliant. I was like, okay, I have to be the last note of this event. How do I keep this level? And then I realized this session is about how we want to build a community to keep thriving and keep developing this point merge concept and hopefully implement it, right? So I actually expect to capitalize on your collective brilliance to make this session a success. And hence, I would like to ask each and every one of you, and also the ones offline, please, online, please, do feel free to send your comments or even raise your hand if you want to speak, and ask you, how can we get to a point where we build together, where we test together, where we validate, and we join forces in order to make point merge a continuous reality and improving reality. So to avoid my colleague Ivan to keep his step count up, we're going to divide the room into two. He's going to take this side and I'm going to take this side. Please, if you have any ideas, if you want to talk about meeting, newsletters, videos, use cases, whatever you want, whatever you think would bring value, frequency, format, please do raise your hand and share it with us so we can take notes and making it happen. You've been very active the whole event, so please don't fail me now. Ivan.
Just from your Claude, from your control, just one suggestion, because when we are speaking about PMS, most of the time in a local situation, we don't have any data on the local situation or local context. So I think it will be good on the wish list when we have to create a profile for any organization connected to the platform, and then to the dashboard, and then up to this organization to put some figures about the context, the local context. For example, does locally there's a management with a departure on the arrivals? How many, for example, delay on the have been expected at first in the design to be absorbed on the point merge, something like that, or maybe other figures. But it will be good for anybody connected and to know about a local context to get this information that cannot be known elsewhere.
Thank you. Okay, so when you go to very touristic areas, they have this thing where they put the flags of the different countries and they say how many money, like how many coins do each country leave. Please don't make me do something similar to see which region is more active and brings more ideas. We have representatives from obviously Europe, but also the Americas. Brazil was around here. Okay. We had as well some Asian also online. So please, come on.
Maybe if I may suggest one thing, I mean, you've seen the presentations from Bruno and Karim. So these are just our ideas at the moment. But of course, we need to validate them with you. And we understand that you guys are extremely busy and you are focusing on your operations for sure. But we would like to really create some kind of a community, something that obviously with a limited minimum effort from you, but really the biggest added value for you to see how we can co-develop and continue looking into these ideas into these new concepts so that you can benefit from it at the end of the day, and also to guide us to make sure that we are looking at the right things. So I think here what we are asking about is really the method, how you want us to do this.
First of all, I think the last 2 days has been really good, really positive. What you learn is the experiences of the other users of ANSPs and how you can improve yours or help to adapt. So the idea of a community, I think, is really important. I think you start off with people who are interested and make it so, I suppose, useful that people then want to join this community and keep wanting to join the community. I think what's really important is that you have a widespread of stakeholders. I think what we found over the last 2 days was you've got ANSPs, you've got the airlines, we need procedural designers, we need EUROCONTROL, the innovation. We may need airports. You know, what does the airport want from this? It was discussions previously around being able to move aircraft around that could suit stand allocations, all of that type of thing. So the more people that we have, the better. I personally think face-to-face meetings when people can get around the table are better than online. I think it's easier to deal with. I think you're right about the time is not easy. But I think if you can hold a meeting every 3 months, 6 months, whatever that it is, where you can get a community together, I think that's the way to do it. From a Dublin perspective, we would be happy to host a follow-up meeting if that was something that was people wanted to do. But I do think face-to-face is the way to go. But getting all of the stakeholders in the room, not just ANSPs and EUROCONTROL, but a widespread of stakeholders.
Thank you very much. And I really welcome your idea about maybe circulating the places of the meetings, because while Brétigny is a wonderful place, as we all agree, it would be good to actually see also other places and maybe beyond Point Merge learn something about your local environment and operations as well. So that's a brilliant idea. Please raise your hand because I don't see you.
I have regretted that. Okay, don't worry. No, I think that when we have seen the map on the Point Merge, it was very interesting. Perhaps sometimes my client is thinking on Point Merge can be useful for me or not. And if I click on the Shanghai one, perhaps an email to send somebody from Shanghai and ask some questions could be useful. It's a little bit a Christmas wish, because it's difficult to find a voluntary for each airport to receive an email from nobody that he knows asking things about Point Merge. But it's creating a Point Merge community. There should be a community, and having different emails for each TMA is a community of people that you can contact with. You are always there, of course. But...
Okay, and that's a nice idea. In fact, I have to say, if I may, we do something very similar in another domain. So 1.5 years ago, we established what we call an ATC automation working group, focusing on ATC automation tools and functions. And we do just that. So first, yes, we have regular meetings. In our case, it's every 2 months. But I think quarterly, perhaps, would be quite a good start here. And also, secondly, we have developed a tool, like an online dashboard, where not obviously for the Point Merge, this is for the automation, but we have a list of tools and automation functions that the ANSPs are using together with the contact details, so that if somebody wants to be, inspired and wants to discuss, break the silos, federate people together, that's what we are trying to achieve there. So perhaps we can do something similar. Of course, there are some limitations to that, GDPR, etc. So in case of the ATC automation tool, or the platform, we don't have it publicly available. It's only available to the members of the ATC automation working group, but we can maybe perhaps establish something similar here as well, if you wish. Okay, I speak too much, sorry.
I just had another idea. I think we all have already many meetings, working groups, whatsoever. These are EuroCAE. I think it would I would like the idea of creating that community and just sharing who of this community is already at some meeting. You know, that once I am in a CSR meeting or EUROCONTROL working group or whatever, I know, there's this other guy who also, or women, who also works on PMS. And I know this in advance to catch up with this person, which I may not know before, that we use opportunities where we meet anyway to leverage those exchange. That would be an idea I have. But it means that we would create a list of people that are part of that and find some means of sharing where we will find each other.
Murat from EUROCONTROL. Having that really big community on this issue, it's a really good idea, and having meetings in different places is a really great idea as well. But from the mobility wise and the having a reaction can be a bit slower than working on the small groups. So maybe I can offer having a kind of really small working forces. For instance, in order to any TMA willing to implement point merge system into their TMAs, a kind of small working group promoting on sharing their ideas and answering all of these questions coming from that TMA could be a very dynamic, let's say, dynamically arranging all of these workforces can be an idea as well.
Some of you were mentioning the wish list before, which obviously it's a very valuable feedback. But thinking about how we can better create a process to capture this feedback and to make sure that it's reflected in our own roadmap, in our own process. Do you think it would be useful to have some sort of annual session or biannual session to talk about potential features, potential roadmap options, maybe both? I don't know if anyone already have processes like that for your own tools, your own systems, but it would be helpful to know how it would be better for you to be involved.
Oh, thank you, Paula. I guess you just said everything right now. There are other groups, NESPs take place. There are people here from LFP that are aware, like in Copens, people usually get some working groups, some have regular meetings, more than one annually. I would say probably on this subject matter, probably one yearly meeting would be good to share some results, some encouraging results, probably inviting some of the newcomers that want to share experiences with us. Probably that's a good way to go and to make a repeatable conference yearly that can probably enhance the community.
Good morning, everyone. I'm Wanda from Portugal. I just want to support this community. For me, as an airspace or flight procedure designer, it's always very difficult to find new information on the new initiatives and how other states are applying these new initiatives. So I really do support. I do agree in a yearly meeting. For me, it's very difficult looking for information online, let's say other states' AIPs. It's sometimes not easy to understand what the flight procedures are exactly and exactly how they're publishing the procedures. So I do support this initiative, and it will be very, very useful for people working in my area. Thank you.
Okay, I think we're doing fine. But I would like to hear maybe from other geographies, maybe newcomers want to throw their hat in the ring.
So Karim is definitely not a newcomer.
Sorry, maybe to along what you say. So it's been said before, we know that you're busy. There are existing fora. We know at AKO, PBN, even EUROCONTROL, there are fora. So the point is not to add another one. and still, we still have the pleasure to meet you again in 1 year. We can keep that. The point is, what can we do in between? So I think you mentioned before, you may look for information, and it will be Fora next time in Dublin or Oslo. The question is, we have people also online, and a lot is going on in other regions of the world. So I would say also to those who are online, how can we build something where we would meet every year in one place, but also in between, how can we work and how can we develop something where we could exchange information, ask a question, and so on. So for me, that's the point. To stress your question, there are people also online. So please also what would you expect if you are not able to join, and if you're able to join in between, what can we do in between the yearly meeting?
And I'm just thinking, do each of the ANSPs here commit to put something up around the basis of their point merge system and maybe the advantages and disadvantages of their particular thing, put it up onto some sort of site, and then provide a contact number for each ANSP if anybody wants to talk, just to start something like that.
Is it me or you, Karim? Me? Okay, I think what Paul is into there is a good way of at least keeping the flow of information alive. If we could have an ambition to perhaps regularly publish like a snapshot of information on what was the purpose of the point merge implementation, what did you achieve, so you can actually get some of the information behind the trajectories and the IARP maps and add them to your dashboard. Then all of a sudden you can have an archive that could look back when you implemented in Shanghai. The reason was to expand capacity. The concept of design was this and this and this, and then you can start interrogating the purpose of the implementation rather than just the actual trajectories. And if you can, in addition, could add contact information, and I think it will be a great archive to share knowledge among those who have implemented, and then a database for those looking into an implementation. Then you can browse through different snapshots of information and see, okay, Dublin, the intentions of Dublin, they are the same as our intentions. Perhaps you should talk to Dublin.
I'm saying up to see. Thank you, Thomas. And indeed, I mean, we would have to be pragmatic and start maybe with those who are already used to share, to meet and to share, and you are very much willing also to, to share more than. So maybe we can start for us to find the way. I mean, in terms of infrastructure, I don't know whether it's a sort of OneDrive or so on, and to share. And then by doing this with your effort and maybe also Elio and Sao Paulo, so Bene has left, maybe this would attract others to join. That could be a good point indeed. We would have to think about that and maybe get back to you. Show by example, and then hopefully others would follow. So let's keep the idea.
To complement the discussion, I don't know if we have a LinkedIn PMS group. For example, we have the Orki page, I don't know how it's called in LinkedIn, where we can put some publications, so the community has clear where to check and look for if there is any important news. So it has not been very complicated to create a point merge group in LinkedIn, and every notice, every news with point merge related, you can put a hashtag EMS. In that way, quickly we will receive Just for LinkedIn, something like that.
Quick question for the audience. If we were to create this page, would you be happy if it's main players of the industry? Would you like to have, for instance, academia involved? Like, how big do you want this community to be? Do you want service providers to be active or only implementers, employers?
I have two comments. First of all, to make sure that, yes, of course, the industry providers should be part, but only those who are actually contributing and not just listening. So that would be my guidance. I would be happy to be part of that. Second advice, because you mentioned the academia. I personally, and this is a bit of a, you had a bit of an emotional start yesterday, so the whole project means something for you. For me, it's also a bit emotional because the EUROCONTROL Innovation Hub, former experimental center, contributed a lot to my personal development with conferences like the ICRAD in the late 2000s or early 2000s. So I would absolutely support to open the floor for academia, for selected universities and really good talents, because I learned yesterday and today that Point Merge covers so many aspects from flight procedure, operations, airline operations, ATC. That's quite a good field of understanding how the whole community works. So that would absolutely be a real benefit, making sure that the new professionals, the younger generation, learns of how this actually works and what their ideas are. And we heard some examples this morning how to further develop that. So absolutely, that would be a great initiative.
Thanks. I wanted to just draw a parallel to the software business because we're more software than ATM, even though I've only ever worked in ATM for the last 30 odd years. But in the software domain, we have plenty of forum online. We have Stack Overflow, we have a GitHub, we have Reddit, we have all sorts of things where you can go in and you can join as a member. There's no restrictions, no constraints, and it's an extremely powerful tool. So why not consider having something similar to that for this community? Not restrictive. I wouldn't say restrict academia, but give them a certain area to discuss in where everybody can join in that discussion. In the same way, we use SourceForge on a daily basis. We use Git on a daily basis. We use all of the Reddit substacks on a daily basis because it's the way you learn about things in software. So I would suggest doing the same in this community as well.
Thank you. Thanks, Jan. And I think I realize that we are maybe on the ATM side, we are a bit hostile compared to you. So, I mean, we have to learn. I mean, it's very much AKO type or EUROCONTROL hostile, and we have to learn what's being done in the more modern domain, if I may say. And I think that should be quite, quite easy to put in place. That does not reply meeting with all of you every year, but that's a compliment. And one thing also, we mentioned academia, so just taking the opportunity, we have Emily, so she's a PhD student from DLR, first year, so I'm happy that also we managed to attract very young people in this forum. So thanks also for Emily to be here.
Actually, I have another controversial question. So we talked about maybe doing this event every 6 months, 1 year, and we talked about the Facebook group. I wanted to ask you because there was another idea floating around when we were thinking about this concept of creating the community, which was the newsletter thing. So I'm not going to ask you for very elaborate arguments, but if those in person and those online can do a little bit of a show of hands of how many of you actually read the newsletters that you receive, it would be fantastic. So great. I think that's good feedback. For those online, you can use the raise your hand button, but I'm not hearing any ping. So either you don't hear me or...
No. It's probably the similar situation.
Perfect.
I read the EUROCONTROL newsletter.
Of course you are. We have a few minutes in case any of you have any additional ideas, any additional comments. If not, I'm gonna segue into Ivan.
So just one other, so for the time being, we are creating long time ago a web page dedicated to point merge hosted by the EUROCONTROL site. So we are providing sometimes newsletter on new implementations and or posts. So it could be also a way to complement what has been discussed previously. Okay, if you have some news or new implementation, send it to us and we can publish. We have a dedicated page for it.
Okay, so thank you very much for all your inputs. Thanks to Paula as well. And we take everything. We were writing notes. Thank you, Emeric, for writing the notes. And maybe the co-pilot was writing the notes with us as well. So we will take that all on board, of course, and we would like to continue the discussion because, yes, this is the concluding remarks, we may say, and wrap up, but we really don't want to stop here. So what we tried to do with this event over the past 2.5 days, we really wanted to take you on a journey from the past, from how this whole thing began, to the current operations, listening from those who have been experienced in operating point merge to show the benefits, but also perhaps some of the limitations and drawbacks, because nothing is perfect and we have always room for improvement. And this is exactly where we were focusing on today, to see how we can further improve these concepts, what we can do together with you, because you are the operational people. You are the people who actually know your stuff better than we do. And that was also mentioned by Bruno and Karim before. So it is you who have the expertise of your local environment and your local operations. That's why we also, with this session that we just concluded, we wanted to establish this communication so that we can work on the right things for you. It was a great journey, I have to say. I learned a lot personally. Hopefully it was beneficial for you too. We will be back, of course, as Arnold Schwarzenegger said once. So we will be back. We will communicate with you if you are okay with that, with some outcomes of these discussions and maybe suggestions for continuing the momentum. We will also share the recording of these 2 days. It will be shared online. We will share the presentations as well to everybody, also to the attendees online. So that will be taken care of. And before we wrap up and before you can go to well-deserved lunch, I'm also obliged to tell you about the future events that we have here at the EUROCONTROL Innovation Hub. So with great pleasure, we would be welcoming you if you wish to join also at the E-Team Promote event, which is happening on the 23rd and 24th of June. You may have heard of that initiative, which is focusing on incremental, short-term innovation for our operational stakeholders. So we will be showcasing some of the solutions that we have developed and we are in the process of developing. And later, after summer, we will also have what we call a meetup event, which is being organized and chaired by Paula, where we actually invite all the innovation hubs, innovators, innovation labs to actually share their experiences and what they have been doing. So it's not limited only to obviously procedures and airspace design. It's the aviation in its broadest sense. So yes, we are continuing with the events. We hope they provide added value to you. And for sure, we will continue the discussions also in the Point Merge community. And I'm already looking forward for the future meetings. And with that, I think we can conclude today. Thank you very much to everybody here. Thank you very much online to everybody. And let's have lunch.